Welcome back, guys. So today we're continuing where we left off. We're looking at question number 1. Let's read it together. A 2-gram sample of a compound gave 4.86 grams of carbon dioxide and 2.103 grams of water upon combustion in oxygen. Find its empirical formula if it only contained carbon, hydrogen, and oxygen. Okay, so in this particular session today, we are going to look at what we started with in the other lesson, or in the first lesson. I hope you watched it through to the end. So now I took the liberty, in the interest of time, just to summarize a question here. By the way, I mentioned before that chemistry is a very logical topic or course that requires a bit of thinking. And part of the process includes what we refer to as data collection. I know you've seen this when writing your lab reports. You don't have to write this when answering. I'm just doing this so it's trying to stress the point. Okay, right. So this is a data collection to what we're going to do. What I'm going to do now is just lay out the steps that we're going to take, okay, in answering this question, and then we can get into it straight away. Like I said, chemistry is principle based. Unless you know the principles, unless you know the procedure, it's very difficult for you to actually answer the questions as you're supposed to. So what we'll do is that the first thing that we're going to do, like we explained in the previous reaction, in the previous class, that we're going to find, we're going to need to have a balanced chemical equation, convert the known mass of reactant or product to moles of the substance, and then use the balance equation and so on and so forth. But of course, this is a unique situation because to start with, we don't have a balanced chemical reaction because the first molecule, we don't know its proportions. We're actually asked to find what this is in this particular case, what this is in terms of its empirical formula. So how we're going to proceed will be a little different, but trust me, it's pretty much the same principle that we've been looking at, or that you've looked at in class so far. If you have looked at it in class, you must have heard this. So we'll take the masses that we are given, take the masses given, okay, and then convert to moles, okay. Then the second thing that we are going to do, which is of interest, or should be of interest to you, I must say, is that, there we are. Second thing that you're going to do is that we're going to then take those moles, okay, the moles, okay, of a molecule into, let me just extend this, the moles of an atom. Then lastly, once we get the moles of the atom, the final step would be to use that information to obtain, excuse me, the empirical formula. Whoops. Formula. Of course, yes, some I've oversimplified it. I acknowledge that, but we don't want to spend too much time outlining. We want to actually answer the question. So let's get into it. So the question tells us that we have 4.86. So start with the carbon dioxide molecule here. Okay, convert it to moles, and then so what we'll do is, let me just explain right here. So we're going to take this given mass, right, and convert it to its its weight, so to say, in moles, or its value in moles. And then we are going to use the moles we get of this CO2 to get the moles of carbon in CO2. I'll say that again. So we'll start with CO2, the mass given, convert it with what we're given here into moles. Then once you get the moles of CO2, we're going to get the mole of carbon. Then we'll also get the moles of, we'll turn this this water molecule into moles. Then we'll get the mass of hydrogen. Excuse me, the moles of hydrogen. And then for oxygen, since it's got 3 of them, we're going to subtract from this 2 grams the sum of the moles from here and from here. Okay, so just stay with me and I'll show you what I mean. So we're going to start now with, so I'm going to use my trusty pen, but for now we can just use this at this point. 86 grams of CO2. Okay, then this is going to be multiplied. In fact, let me just use my free pen so that you see how this is going. So 4.86 grams of CO2, right? Then we're going to multiply it. So now we're changing this into moles. Not so. So CO2. So we need to use the molar mass. So carbon has the atomic mass of 12.01. And then we have the oxygen. So there are 2 oxygen molecules. And then there are 16, so it's 16.00. So when you add the 2, it should give us 44.01 grams, okay, of CO2. Okay, so that's what we're going to use. It will give us 44.01 grams of CO2. Excuse me. Yes. So we're going to use this mass here. CO2, like so, like that. Okay. Okay, so we have that there. We can wrap that off. So we're trying to say, so this is the molar mass, and the molar mass of CO2 is 44.01 grams per mole. Yeah, grams, okay. And when you say per mole, we mean 1 mole. So we say 1 mole of CO2. Now I can't put a 2 down there, so we're just going to have to do it separately. Okay, there we go. Then we have our 2 there. Okay, so that the one that we get on top here, so now after doing this, you'll notice that the grams, let me use a different color. Again, I'll try and go as slowly as possible so that we get it. So the grams, the grams of CO2 cancel here and the grams cancel here. so that what remains are the moles. Okay, so that's pretty much how it works. Then we can continue. Okay, so we have times there. Let's try and practice with our free hand so that we do not, oopsie daisy. Okay, ooh, okay. Okay, that was quite nice. So now we're going to now get the mass, the mole of carbon. So if there is a mole here, if the mole is on the numerator here, we're going to include it on the denominator so that it cancels out. So 1 mole, 1 mole of, let's do that again. 1 mole of CO2, okay, gives us, 1 mole, okay, 1 mole of carbon, okay. Then, so once this takes place, this will cancel and this will cancel out. Then we have times sign there. Okay, so we know that 1 mole of carbon will give us 12. So you have to use a periodic table here, 12.1 grams or gram of carbon. Okay, so that this here and this here will cancel. And then what we have is 486. And then the answer that we're going to get is 1.326 grams. Okay, and we have that there. Okay, so that one is for the first calculation. Then the second one, we're going to use 2.03 grams of water. Excuse me. I don't know, I keep on saying water. It's got a nice ring to it. Water. Okay. There we go. My writing will be a bit big now because it's easier that way. If I start writing small, I want to show it is a problem. 6 grams of, so starting with the measurement that we're given, we're now trying to calculate this into moles. So we know that 1 mole, 18 point, wow, that is incredibly excruciating. There we go. Finally, now that looks like a 1. 18.0, so there's a point here. 18.016 grams of water is the same as 1 mole of water. 1 mole of water. Okay, like so, like that. Okay, so that when you cancel this and we cancel this, we remain with moles of water. All right, then the next step is we're going to say 2 moles. Actually, let's start with the denominator so that we follow properly. So now again, 1 mole. So now we're getting the mole of hydrogen. So 1 mole of water, as you can see on the numerator in the neighboring one there. 1 mole of water gives about 2 moles of hydrogen. Okay, 2 moles of hydrogen. All right. Okay. Just listen to the sound of my voice. Because if you look at the neatness, you may not follow very well. So pardon me. There we go. So 2 moles of hydrogen will give about 2.016 grams of hydrogen, like so, like that. Okay, so let's see if we can make sense out of this. So this is the amount that we're given of water that is produced. And then we said that we want to change the grams, the grams or mass were given into moles. So what we did was we took the molar mass of water, which is 18.018, okay, over thing, and how we arrived at the 18.108. Water, hydrogen is 1.008, and there are 2 of them. So it is 2 by that, then plus oxygen, which is 16 if you are following the periodic table, 00, that's 1600, like that, giving us 18.6, 18.16. Okay, for those of you who are not following there, right, then once that has taken place, so once we have the moles, so remember we've cancelled this, we've cancelled that, we remained with the moles, okay, and then we multiplied, we wanted to find the number of moles of now just hydrogen instead of the whole, now just hydrogen. Okay, so how we did that, we went about it by saying 1 mole of every mole of water has 2 moles of hydrogen there. Okay, then we're going to use this mole of hydrogen to get the grams of hydrogen itself, which is, so you can just type it in the way it is appearing. The answer is, okay, 0.007 grams of hydrogen. So that is going to be 0.22 grams, okay, of hydrogen. Right. So that's what we're going to do. So this was, let me put a star, excuse me, put a star here and a star here. Then the third point, so that was for hydrogen. So now we want to find the grams of oxygen. So we take the 2 grams. Okay, where is it coming from? If you come back with me, you remember that this is the mass of the whole. So we're going to subtract what we got out of the CO2, the carbon from the CO2 and the OH from the water there, and subtract it from 2. So 2 grams minus, then we'll open a bracket there. We say 1.326. Okay, then plus 0.007 227. Okay. Then the answer here. So let's see. So if you just type it in the way it is appearing, so 2 minus 1.326 plus 0.007 close bracket, we are going to get 0.44 and 7. Okay, 0.447 grams of oxygen. So we have for carbon here, we have for oxygen, and we also have for oxygen there. Okay, so the next thing that we're going to do, oh yeah, and when you add this value here, as well as this value here, it should add up to 2. Okay, or as has been given in the question, 2.00. Just by the way, if you have questions, please feel free to email me. I'm sure I'll be able to answer them. Okay, right, then we can continue. So the next step is to change each of those grams, the ones that we calculated, here, and here, into moles, so that we find the empirical formula in the final step. So this will be part 2. Whoops, that's a very interesting looking too. There we go. So we start with the carbon. So carbon is 1.3. Let me draw this decimal point. 1, yeah, let's do that. 1.326. Please take note, it's not 1,000. It's just if I add a dot there, it doesn't look very good. So when I do this, so that's a decimal point, but I know it looks like a comma, but it's supposed to be a decimal point so that it's visible. So just pardon me there, ladies and gentlemen. Okay, then we're going to say the same conversion thing that we've been doing. So that's grams of carbon, the one we calculated. So we're going to take this and find the number of moles of this same measurement. So we know that for every gram of, we know that in every carbon atom, there is actually 12, okay, 12.01 grams of carbon in every mole of carbon. In every mole of carbon, okay? And if you type that in, so it's 1.326, 1.326 divided by 12, giving me 0. So I'll just do that. 0. 0.0, nope. 0.110. What is this? Moles. Okay. That doesn't look right. Moles of carbonino, of carbon. Okay. Then we have the second one, which we found was, let's see what number it was, 0.00, this one here, 0.227. So 227 grams, okay, of, what was that again? hydrogen, yes, of hydrogen. Okay, like so, like that. So we know that in every gram of hydrogen there is one. So in 1.008 grams of hydrogen, there's actually 1 mole, okay, of hydrogen. And when you put that in together, so 7 divided by 1.008 gives us 0.225 moles of hydrogen. Okay, and then we also have the last one for oxygen, which is 0.447. So 0.447 grams of oxygen. We multiply that, so we know that in every 16 grams, okay, in every 16 grams of oxygen, 16 grams of oxygen, we have 1 mole of oxygen. Okay, so 0.447 divided by 16, 0. Okay, so of course this and this will cancel, and we have 0.027. That's 28 actually. Okay, moles of oxygen. Right. Then the final step would be to divide each of these with the smallest value here, and the smallest value is of course this one. So we'll start with that same one. So we then divide by that all 3 of them. Okay. 0.028. Okay. Then we also have 0.028. Okay. So that here we're going to have, so we're going to divide to give us our final values. So 0.110 divided by that gives a value of 4. Then the other one, 5 divided by 0.028 gives a value of 8. Then this one, of course, will give a value of 1. Okay, so therefore our final answer will be C4H8 and then O1. So that's the answer. Okay, so just to recap, we converted the masses that were given, okay, and converted them into moles. And then we use those moles to get the moles of an atom, and then use that information to get the molecule, to get the period, the empirical formula like that, okay? So that's how we get the empirical formula. So the problem solving strategy, really, as stipulated in Zumdal, is that when you solve such questions, like I was mentioning in the previous lesson, is that you first have to begin by balancing the equation. You have to also convert the known mass of each reactant or product to moles of that of the substance, then use a balanced equation to set up the appropriate mole ratios, then use the appropriate mole ratios to calculate the number of moles of the desired reactant or product, convert from moles back to grams if required by the problem. All right, so thank you so much for joining me this time. I hope this was helpful. Have a nice